vector product or cross product of two vectors. The statement is the vector product or cross product of two vectors is a vector space. A vector and B vector is another vector, a C vector, whose magnitude is the product of magnitudes of the two given vectors and sine of the smaller angle between the two vectors. Okay, so how we represent it? Vector A cross vector B, and we read it as vector A cross vector B. So vector of cross product of two vectors, A vector and B vector, is another vector. Now the result of these two vectors, the cross product of these two vectors, is another vector. If you remember, we have studied prior to this that in case of dot product, the result is a scalar quantity, but now in case of vector product or cross product, the result is a vector quantity, and that is why it is called a vector product. And the magnitude of the result of the cross product of two vectors is the product of the magnitudes of the two vectors and the sine of the angle, the smaller angle between the two vectors. So A cross C, that is how we represent the cross product of two vectors. Let us say if theta is the smaller angle between vector A and vector B, then as per the statement, A cross B is equal to C vector and is equal to A B sine theta and direction along a unit vector C. So here this is the magnitude and this is the direction, because C vector will be given by the magnitude of C vector product multiplied by the unit vector along C vector. So this is how we represent unit vector of C vector. So C cap is a unit vector in the direction of C vector. So C cap is unit vector in the direction of vector C. So vector product of two vectors gives you another vector. And this direction of the C vector is given by right-handed screw rule as well as right-hand thumb rule. So two ways in which we can find out the direction of the cross product of the two vectors. So one is right-handed screw rule and second is right-hand thumb rule. So these two rules we can use to get the direction of the cross product of two vectors, that is the direction of vector C. Now, what is right-handed screw rule? According to this rule, suppose if a right-handed screw is placed with its axis perpendicular to the plane containing the two vectors, the vectors A and B, is rotated from the direction of vector A to the direction of vector B to smaller angle. Then the sense or direction of the advancement of the tip of the screw gives the direction of vector A cross vector B, that is vector C. So we have a right-handed screw. Suppose this is a screw, this is the cap of the screw, and this is the tip of the screw. We place it, suppose this is the plane in which vector A and vector B are located. We place this cap of this right-handed screw on the plane of paper and keep the axis perpendicular to the plane. And then we turn the screw in the direction from direction of vector A to vector B. Then whatever be the direction of advancement of this tip of the screw will give us the direction of vector C. So we have to remember one thing. The C vector is perpendicular to the plane in which vector A and vector B are located. Now to understand this, we can draw a figure and understand this better. Suppose this is a plane in which vector A and vector B are located. So this is vector A direction in magnitude and direction, vector B. This is the smaller angle between the two. So one thing we must remember, if this is in the plane of the board, the direction of vector C will be either perpendicular to the plane containing the two. It may be in the upward direction, it may be in the downward direction. So now we have to place a screw like this. This is the cap of the screw. We place it here, and we are trying to find out A cross B. Then you move from the direction of, you turn the screw from the direction of A to the direction of B. So like this. So when we turn the screw like this, we know we are going towards the right direction. The tip will advance in the upward direction. So therefore, the direction of vector C is given by a vector which is perpendicular to both and in the upward direction in this case. You can imagine a screw here. So this is a screw. Okay. So when you turn the screw from this side to this side, you'll get A cross B. Okay. Similarly, if you want to find out B cross C, so B cross A, then you have to turn the screw from B vector from the direction of B vector to A vector. So when you turn it from B to A like this, the tip will go down. In that case, the direction will be again perpendicular, but now in the opposite direction. That is downward, because the tip is advancing in the downward direction. Okay, so that is how we can find out the direction of the C vector. Now we can find, let us discuss right-handed or right-hand thumb rule. In the last example, you must remember that if the result of A cross B, you can see from here, is not same as B cross A. The magnitude may be same, but the direction will become opposite. Because direction of C vector is in the upward direction, perpendicular to the plane, but direction of C dash vector, that is of B cross A vector, is in the opposite direction, that is downward. So right-handed thumb rule, according to this rule, if we curl the fingers of right hand, keeping the thumb erect, keeping the thumb erect in such a way that the fingers point in the direction of rotation from vector A to vector B through smaller angle. Then the thumb points in the direction of vector A cross vector B, or you can say vector C. So this is very simple. You have been using this kind of rule to find out direction. So you can look it at here. Once again, we'll draw the two vectors in xy plane, for example. So this is A vector and this is B vector. This is theta. We want to find out A cross B. So what we do is we keep our hand like this and we curl the fingers from the direction of A vector to the direction of B vector. You can see this is the direction of A vector, and we are going towards the direction of B vector through smaller angle theta, and we're keeping the thumb erect. So the direction of thumb gives us the direction of C vector. Now this direction of thumb is perpendicular to the plane in which A vector and B vector are located and in the upward direction. So this is the direction of C vector. So this is how we can find out the direction of C vector with the help of right hand thumb rule. Now again, if we want to find out vector B cross vector B A, we want the result of vector B cross vector A. Then now you have to curl the fingers from the direction of B vector to the direction of A vector to smaller angle theta. So now you can see the fingers are pointing towards in the direction of B vector and moving, curling towards the direction of A vector. And the direction of thumb is giving us the direction of C vector. So again, the C vector is perpendicular to the plane. Now we call it C dash vector, perpendicular to the plane, but in the downward direction. So this is how we can find out the magnitude and direction of the cross product of two vectors. So magnitude is AB sine theta, and the direction is given by right hand screw rule as well as right hand thumb rule. Now let us discuss the geometrical representation of vector or cross product of two vectors. Geometrical representation of vector product of two vectors. Let us consider two vectors, vector A and vector B. Suppose this is vector A represented by OP, vector OP that is, and vector B is represented by another vector OQ, and the angle between the two is theta. Okay. Now we can complete the parallel two vectors acting at the same time, for example, and they are joined, they are represented by two adjacent sides. Let us complete the parallelogram. Parallelogram OP. Suppose this is R and this is Q. So OPRQ is the parallelogram. Now let us drop a perpendicular from Q on OP. Let us say this is QN. So QN is perpendicular to OP. Join P and Q. So we have dropped a perpendicular from Q on OP, that is Q1 perpendicular to OP, and we have joined P and Q. Now the magnitude of A cross B is given by AB sine theta. Okay, so what is AB? The magnitude of AB in A in this case is OP. Magnitude of B vector in this case is OQ, and sine theta. So sine theta, we can write down sine theta as it is. Now let us get sine theta. So sine theta from the triangle ONQ. So triangle ONQ, sine theta is equal to given by QN divided by ON. Divided by Q. So QN divided by OQ. So therefore, QN is equal to OQ sine theta. So vector A cross vector B magnitude is equal to, now replace this by Qn because OQ sine theta is equal to Qn. So we'll get OP as it is. Instead of this, we'll write down Qn. And what is OP multiplied by QN geometrically? OP multiplied by QN is giving you the area of the parallelogram, that is OPRQ. So it is giving us the area of parallelogram. So geometrically, you can say that the magnitude of A cross B, or the magnitude of vector A cross B, is equal to the area of the parallelogram. So magnitude of A cross B is area of the parallelogram whose two adjacent sides are represented by the two given vectors. So I can conclude here the magnitude of vector product or cross product vectors.
So the magnitude of cross product of two vectors is equal to the area of parallelogram whose two sides are represented by the two vectors. So the magnitude of cross product of two vectors is equal to the area of the parallelogram whose two sides are represented by the two given vectors. If you look at it, see if QP is dividing the parallelogram into two equal triangles. So we can also say that the magnitude of the two vectors is equal to the twice the area of a triangle. Twice the area of a triangle whose two sides are represented by the two vectors. This is a triangle OPQ. The two sides OP and OQ represent the two given vectors, and area of this triangle twice of it. Because area of the parallelogram is half the area of this triangle. So the magnitude of the vectors of the cross product of two vectors is equal to twice the area of a triangle whose two sides are represented by the two given vectors. So these are two ways of getting the geometrical representation of magnitude of two vectors. Special cases of cross product. So one is when vectors are parallel or anti-parallel. That is theta is either 0 degree or 180 degree. So in that case, the sine theta, the value of sine theta, which is sine 0 or 180 will be 0. Because the sine theta value is 0, so magnitude of A cross product, which is given by AB, sine theta will also be 0. Okay. And therefore A cross D vector, which is equal to C vector, will be 0 into C cap, that is 0. And cap on top. So therefore, I cross j, that is along x-axis, unit vector along x-axis, cross product unit vector of y-axis is equal to j. Now instead of this, unit vector along x-axis and unit vector along x-axis. That means angle between the two is 0. So j cross j angle is 0. K cross k angle is 0. So result will be 0 cap. So cross product of two vectors, two parallel vectors, the anti-parallel vectors is 0. Now when vectors are perpendicular, that means theta is 90 degree, sine theta will be 1. So therefore A cross B, which is AB sine theta C cap, will be equal to AB multiplied by 1 C cap. So will be equal to A B C cap. Okay, so cross product of two mutually perpendicular vectors is a vector whose magnitude is equal to the product of magnitudes of the two vectors, and the direction is perpendicular to the plane containing k vector and b vector. So that is the cross product of two vectors when the two vectors are perpendicular to each other. So I cap cross j cap, this is along x-axis, this unit vector is along y-axis, angle is 90 degree, will be equal to j cap cross k cap will be equal to k cap cross I cap. So angle between all these unit vectors is 90 degree, and the values are not equal. So I cap cross j cap, that is along x-axis unit vector and unit vector along y-axis, the cross product will be unit vector along z-axis, because it is perpendicular. As I said, C cap is perpendicular to the plane in which A and B vectors are located. So I cap and J cap are in xy plane and K cap is in the z direction. So J cap or cross K cap will be I cap, and K cap cross I cap will be J cap. Okay. And if you remember, J cap cross I cap, B cross A direction becomes opposite. So it will be minus K cap, K cap cross J cap will be minus I cap, and I cap cross K cap will be minus J cap. So now, because we know that A cap cross B cap, sorry, A vector cross B vector is equal to minus B vector cross A vector. So if you remember, result is C vector and this result is C dash vector, but it's the opposite direction. So therefore, A vector cross B vector is equal to minus B vector cross A vector, and that is one property of cross product of two vectors. So properties of cross product. So one, as we have already discussed, A vector cross B vector is equal to minus B vector cross A vector. So it is anti-commutative. So one of these property is called anti-commutative. And depending on this, we have said that j cross I is equal to minus k and so on. Okay, so this can be we have already proved this with the help of right hand screw rule as well as thumb rule, right and thumb rule. In the few minutes back, let me prove this. So, product of two vectors is distributive. Distributive. So what is distributive? That is, if we have two vector cross b vector and plus c vector, this will be equal to a vector cross b vector plus a vector cross c vector. So that is distributive. And third, because if we take the sum of the two vectors and the resultant is used in the cross product of a vector and the resultant of the two sum of the two vectors will give you the a vector cross b vector, one vector plus a vector cross c vector. So cross product is distributive as well as cross product is associative. Of two vectors, now here it is more than two vectors, so write down cross product of vectors is distributive and cross product of vectors is associative. So that means a vector plus b vector cross c vector plus b vector will be equal to a vector cross c vector plus a vector cross b vector. So this cross plus b vector cross c vector plus b vector cross d vector. Okay. Now examples of cross product. So examples are, one example is torque. Torque presented by tau vector. So it is the torque acting on a particle is equal to the vector product of cross product of the position vector and force vector. So it is equal to r vector cross f vector. So torque is given by the cross product of the position vector of the particle and the force acting on the particle. Another example is angular momentum, which is represented by L vector, capital is the cross product of position vector and the linear momentum vector. So these are two examples of cross product of two vectors. There are many other examples also. Now cross product in Cartesian coordinates. Cross product in Cartesian coordinates. Suppose the given vector A vector can be represented in Cartesian coordinates as Ax I cap, Ay j cap, plus Az k cap, vector B dx I cap, dy j cap, dz k cap. And we want to find out A cross B. Maybe Ax I cap always cross Bx I cap and all this. So now first we will get the cross product of this with this whole. So we can write down Ax I cap cross bx I cap plus by j cap plus bz k cap plus now ay j cap cross this whole thing plus az k cap cross this whole thing in the bracket. Okay, now we can get the cross product of this because cross product of two vectors is distributive. So this will distribute on with this. So ax bx are magnitudes and I cap cross I cap plus ax by I cap cross j cap plus ax bz I cap cross k cap. Similarly, plus ay and dx j cap cross I cap plus ay dy j cap cross j cap plus ay bz that is j cap cross k cap plus az dx k cap cross I cap plus az by k cap cross j cap plus az bz k cap cross k cap. Now look at this. This I cap cross I cap, j cap cross j cap, k cap cross k cap. The angle between these unit vectors whose cross product we are trying to find is 0. So that is, and the angle is 0, sin theta is 0. So the value of this is 0. So this will become 0. So these three will become 0. Now I cross j will give you k cap because angle is 90 degree and k cross I gives you j cap, but now I cross k. This is like d cross k. So it will be minus j cap. And we already have discussed this that I cross j is equal to k, but j cross I is equal to minus k cap. Similarly, k cross I is j and I cross k minus j. Another one is j cross k is I, but k cross j is minus I. So using this, we are going to replace these values, and now j cross I is minus k here. So this is minus k, and this will be, this is j cross k is I, k cross I is j, and k cross j is minus I, and k cross k is 0. So let us put the rest of the values. Remove this, so we'll get ax by and k cap plus ax bz minus j cap plus ay bx. Now j cross I is minus k cap, and now ay bz. Now j cross k is I cap and plus az bx j cap plus az by minus I cap. Okay. So now we get something common here. This is I cap and AZ BY, sorry, minus, and this is I have common plus now I talk about J. So this is minus J and this is plus J. So write down A as Z Bx, this quantity minus Ax Bz into J cap plus now K Ax By minus Ay Bx. Okay, so this is what we finally getting. Now this can be presented in terms of a determinant. It will look like this. So A cross B will be given by determinant. So I cap J cap K cap have Ax Bx Ay By Az. So this result that we have got is the result of is the solution of this determinant. Okay. So this is about vector product or cross product of two vectors, and this is how we solve the cross product of two vectors in Cartesian coordinates. So if we have the values Ax, Ay, Az, Bx, By, Bz, and we want to find out the magnitude of A cross B, rather to find out the result of A vector cross B vector. So just make this determinant and solve it, and you will get directly the value of A cross vector B, and this is what you will get Ay Bz